question is from GATE 2016, Mechanical Engineering paper, set 3, question number 34. Two circular shafts made up of same material, one solid denoted by S and one hollow denoted by H, have the same length and polar moment of inertia. Both are subjected to same torque. Here, theta S is the twist and tau S is the maximum shear stress in the solid shaft, whereas theta H is the twist and tau H is the maximum shear stress in the hollow shaft. Which one of the following is true? Option A, theta S and theta H will be equal in both cases and maximum shear stress will also be equal in both cases. Option B, angle of twist in solid will be greater than angle of twist in hollow shaft and maximum shear in solid will be greater than maximum shear in hollow shaft. Option C, both angle of twist and maximum shear for solid will be less than angle of twist and maximum shear for hollow shaft. Or option D, theta S will be equal to theta H and tau S will be less than tau H. Let's find out. Let's write the given things. For solid shaft, we'll give a subscript of S and for hollow, we'll give a subscript of H as given. So it's given that the shafts are made up of same material, hence their shear moduli GS and GH will be equal. Let that be G. Then we have their lengths are equal. So LS is also equal to LH is equal to L. Torque applied is equal. TS is equal to TH is equal to T. In fact, the polar moment of inertia are also equal. JS is equal to GH is equal to G. So by pure torsion equation, we have T by J is equal to G theta by L is equal to tau by R. If for the first case we want to check the angle of twist theta can be obtained by rearranging these two terms, the first two ratios. So we get TL upon GJ. Now as all of these physical quantities are equal for both the solid and hollow shafts, we can write that angle of twist for solid shaft is equal to angle of twist for hollow shaft. But what about the second one? Maximum shear stress. For maximum shear stress, we'll consider the first and the third ratios. Now we can write T by J is equal to tau by R. So shear is given as T by J into R. We know that T and J are same for both of the shafts, but R is not same. We don't know about how the radius will be. By logic, if the solid shaft is to have the same polar moment of inertia as the hollow shaft should be greater in radius than the solid one for their polar moment of inertia to be equal to each other. So we can write that JS is equal to JH. If we want to substitute JS in terms of radius, it is for circular geometry, it is pi by 2 r to the power 4. Let's give an S for the solid is equal to, for hollow shaft, it will be pi by 2 into outer radius. So let that be RHO raised to 4 minus inner radius of the hollow shaft, RHI raised to 4. We have just subtracted the polar moment of inertia of outer circle minus the inner circle. Now from this equation, pi by 2 and pi by 2 cancelled out from both sides. So if we compare RS and RH naught, RS4 is directly equal to now RH naught raised to 4 minus RHI raised to 4. We see that RH naught ought to be greater than RS. It will have to be greater than RS. So if the outer radius of the hollow shaft is greater than RS, we know that maximum shear in case of solid shaft is given as T by J into its farthest fiber. That means at RS, at the outermost periphery, which is at a distance RS from the center. So this is the maximum shear in case of solid shaft. For the hollow shaft, however, T by J into, although it's a hollow shaft, the fiber that is farthest from the center is at the outer radius itself, outer periphery or the outer radius. Hence this will be RH naught. So clearly from these two equations we can see that because RS is less than RH naught, shear stress in case of solid shaft is also less than shear stress in case of hollow shaft, both being the maximum shear stress in both conditions. Let's mark the correct option. Our correct option is option D. Angle of twist will be equal in both cases, while shear stress will be smaller for the solid shaft and greater for the hollow shaft. To learn more about torsion in shafts, you can refer to the NPTEL video Lecture 18 Torsion 1 from the course lecture series on Strength of Materials by Professor S. K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.